This integral becomes very simple when you divide top and bottom by e to the x. So when we do that, everything becomes very simple. So let's do that. We have I to be equal to the integral. I'm going to write a long one from 0 to 1 of 1 minus x. I'm going to divide this one by e to the x. Right, so let me do that in a different color. Why not? So this is e to the x, and now at the denominator, I'm going to divide that one by e to the x as well to maintain equality. So e to the x. So this is what we have. So when we do this, what do we get? We have the integral from 0 to 1 of the numerator will stay the same, 1 minus x all over e to the x, right? Then I'll have the x here. This is divided by, this is the square root of e to the 2x minus x squared. But this one is divided by e to the x can be written as the square root of e to the 2x. Alright, so we have I to be equal to, everything is going to simplify in the next line. So we have the integral from 0 to 1 of 1 minus x. This is divided by e to the x, all this one dx, and this is divided by, so now we are going to have this one all in the square root. So e to the 2x divided by e to the 2x, that is going to be 1 minus x squared all over e to the 2x. So this is the integral from 0 to 1 of 1 minus x all over e to the x, the x on top, and then divided by the square root of 1 minus x squared over e to the 2x can be written as x over e to the x, all this one squared. Alright, so now let's do a substitution and then we'll see that everything will simplify. We are going to let u to be equal to x over e to the x, just this. So let's differentiate the u, the x. We are now going to differentiate this using the quotient rule. So we are going to keep e to the x constant and we differentiate x, which is 1, minus we are going to keep x constant and we differentiate e to the x, and that is going to be e to the x. All this one divided by e to the x squared. So du dx is equal to what really? So that is going to be e to the x minus x e to the x. This is divided by, this is e to the x multiplied by e to the x at the bottom. So that is going to be e to the x can be factorized out in the numerator. Then you have 1 minus x. This is divided by e to the x times e to the x. And we see that this one is going to cancel this one out beautifully. And what we are left is this. So an expression for du is going to be equal to 1 minus x all over e to the x dx. So this is what we have. What about a change in limits now? So let's find the change in limits. So when x is equal to 0, that is the lower limit for x. What is going to be the value of u? U is going to be 0 over e raised to the power 0, and that is equal to 0. That is from here. And when x is equal to 1, the upper limit u is going to be 1 over e to the 1, and that is 1 over e. So this is the change in limits. Now the integral in the u world is going to look like this. I is going to be the integral, the limits of integration now from 0 to 1 over e. Alright, of what really? So we see that 1 minus x divided by e to the x dx, that is something. 1 minus x divided by e to the x dx, that can be replaced with du. So we have du on top here. This is divided by the square root of 1 minus something, divided by the square root of 1 minus x over e to the x. X over e to the x can be replaced with u. So that is u squared because it is squared. And does this look familiar? So the integral of 1 over the square root of 1 minus u squared. So let me refresh your memory. So if you have the sine inverse, so if you are differentiating the sine inverse of x, this is the same as 1 over the square root of 1 minus x squared. So in that case, if you are integrating 1 over the square root of 1 minus x squared with respect to x, that is going to yield the sine inverse of x. All right, so here what we can do is this one is the same as the integral from 0 to 1 over e of 1 all over the square root of 1 minus u squared du. So this one is just the arc sine of u. So I is going to be the sine inverse of u, the limits of integration from 0 to 1 over e. So what we can do here is just to plug in the limits of integration and we are done with the integral. So the sine inverse of 1 over e minus the sine inverse of 0. Sine inverse of 1 over e is sine inverse of 1 over e. Nothing to simplify here. And sine inverse of 0 is 0. And this one is the answer to this beautiful integral. Alright, very simple. So this is an MIT Integration B question and it appeared in the 2026 regular season. And the answer to this is the sine inverse of 1 over e. What a beautiful answer to this beautiful integral. So if you find that helpful, give me a thumbs up and subscribe to Calculus Diaries, and then I will see you in the next one. Bye bye.